Okay, let's do problem 5. Sorry, problem 4, part 4. Okay, so here the integration, right? You need to integrate 1 over x times x squared plus 5. Okay, so here we need to use something called the partial fraction. Okay, why partial fraction? Because this part itself, it's not so hard to integrate, right? And this part itself is not so hard to integrate. But together, right, it seems very hard to integrate. So we do something called partial fraction, which means we want to split this fraction into the sum of something over x, okay, plus something over x squared plus 5. Okay, then here, because the bottom is x, so just remember the top. Okay, first, why it's x and x squared plus 5, because these two are the factors of this bottom. And always remember the top is 1 degree lower than the bottom. Right, so here, the first one, the degree here is 1, x to the power of 1. Right, so the top, it should be x to the power of 0, which is a constant. And you don't know what that constant is, so you can call it a. Okay, the same reason here, the bottom, the power of the bottom is x squared, is 2. Right, so the top, it should be x to the power of 1 plus some constant. Okay, so just always remember the top is 1 degree less than the bottom. So the top, let's call it bx plus c. Okay. Then, so you can see here, the bottom, the degree is 1, so the top degree is 0. Bottom degree is 2, the top degree is 1. So then, we just have to solve. Right? We just have to get the value of a, b, and c. So it is x times x squared plus 5. Okay, so this part is a times this. So it's a times x squared plus 5. Right, plus this times this. Right, plus x times bx plus c. Okay. You just need to organize. So the top is, here we have ax squared, we have bx squared, so it's a plus b x squared. Okay, bottom, sorry, we have 5a, right? We also have cx, so it's plus cx plus 5a. Okay, then all we need to do is compare this with this, right? This whole part, it should be 1, okay? Because it's always equal, equal, equal. So this part, it should be 1, right? So you can see the constant is 1. Here it's 5a is a constant. Here it is 1, right? So 5a is equal to 1. And here, we don't have any x. There's no x here, and there's no x squared here. Right, so this part and this part, both of them, they should be 0. Okay, c should be 0 and a plus b should be 0. So basically this part, it should be equal to 1. So this is 1, right? This should be 0 and this should be 0. Okay, then you just need to solve this. A is already given, it's 1 over 5. C is just 0. And a plus b is 0, so b is negative 1 over 5. Okay, b is negative 1 over 5. So that's the first step. So now we can split this integral as a over x, which is 1 over 5 x, right, plus bx plus c. So it's negative 1 over 5 x over x squared plus 5. Okay, here, this 1 over 5, it's a. Okay, this negative 1 over 5 x, this is bx. Okay, c is 0, so here it's 0. Right. And now the integration is much easier. So the first part, right, you integrate x, what you get is x squared, right, half x squared, and you have a coefficient 1 over 5. Okay. Then the second part, minus 1 over 5. You integrate this part. Okay, when you integrate this part, you can use the substitution method. Right, so it's 1 over 10. Wait, sorry. Here's a typo. Right, it's 1 over 5 times x. So here the x is on the bottom. Sorry about the typo here. Okay, so it's 1 over 5. And if you integrate 1 over x, what is it? It's lowering absolute value of x. Right? It's lowering absolute value of x. So here, this x is on the bottom, it's not on the top. And this part, how do you do the integration? You can do it here. Right? X over x squared plus 5 dx. So you can use the substitution method. U is x squared plus 5. Then your du over dx is 2x. Okay, so here your your half du is x dx. So here it's like you integrate 1 over u, right, half du. Okay, because this dx times x, this part, right, dx times x, it's half du, right, it's just this part. Okay, and this 1 over x squared plus 5 is just 1 over u, right? So the result is half lowering absolute value of u. Okay, half lowering absolute value of u. So it is minus 1 over 5 times half lowering. So absolute value of u, what is u? Right, u is x squared plus 5. The absolute value of x squared plus 5. Okay, plus c. So the answer is 1 over 5 lowering x minus 1 over 10 lowering x squared plus 5, right, plus c. Okay. Do you have any questions for this one? Yeah.
You're recording?
Yes. Yeah.
Sorry, I don't speak.
Okay, it's okay. Part E. Right, you want to integrate 3x squared plus x minus 1 over x squared times x plus 1. Okay, again, you want to do partial fraction for this part. Okay, you want to do partial fraction for this part. Here, not only you have x, you also have x squared. You have x plus 1. Right, so for each of them, you should have a part. So it's x squared, and x plus 1. Okay, so again, for x, you should expect some number a. And for x squared, okay, because here, it is still from x, so we still just get a number b. And then for x plus 1, we have a number c. Okay. Then it is x squared, x plus 1. Right? So for this part, it needs to times x plus 1. So the top needs to times x plus 1. Okay, so it's a times x plus 1. And then plus b times, so it's already x squared. So it's b times x plus 1. Okay, plus c times, so it already has x plus 1, so it's c times x squared. Right. Then you just need to solve it. So it's ax squared plus a plus bx plus b plus cx squared over x squared x plus 1. Okay. As you can as you can see here, ax squared, cx squared, the sum, it should be 3x squared, right? So a plus c should be 3. And then here we have bx, so I have x here, so b should be 1. Right? And I also have -1, I have a plus b, so a plus b is -1. Okay, again, just solve it. So b is 1, a plus b is -1, a is -2, c plus a is 3, so c must be 5. Wait, is there any mistake? Yeah, here's a sorry about the typo again. So here is ax squared, and here is ax plus times 1, right? So here it's ax. So that's why, no, so it's ax plus bx is x. So actually it's a plus b is 1. Okay. And then actually we only have b here, and we have -1 here. So b is -1. Okay, so b is -1, so a is 2, and c is 1. Right. Then we can write down the integration. So it is a over x plus b over x squared plus c over x plus 1 dx. Right. And this integration is much easier, so it's 2 ln x, right, minus, here it's 1 over x, right, -1 over x. Right, if you integrate this, which is just plus 1 over x. And then here it's just ln x plus 1 from 1 to 2. Okay, and just sub in, so it's 2 ln 2 plus 1 over 2 plus ln 3 minus, right, 2 ln 1 plus 1 over 1 plus ln 2. Okay, then you just do it. It's -½ plus ln 2 plus ln 3. Okay, so this is part E. Last part, part F. We integrate 4x over x cubed plus x squared plus x plus 1. Okay, first thing, you have to find that, right, first thing you have to write down the bottom, you have to factorize the bottom. Okay, so how do you factorize the bottom? You see that here, you have a common factor, x squared. So it's x squared times x plus 1 plus x plus 1. Okay, so this is the bottom, and you have a common factor, x plus 1. Right, so that's why you can write it as x plus 1 times x squared plus 1. Okay, 4x. Right, just get the common factor, because here this part is just x squared times x plus 1, right, and plus x plus 1. So now this is a common factor. Right. You can write it in this way. And after here, what should we do? Again, we should do the partial fraction. All right, so your 4x over x plus 1 times x squared plus 1, you should be able to written as a over x plus 1, right, plus a bx plus c x squared plus 1. Okay, then you do the same thing. So it's x plus 1, x squared plus 1, a x squared plus 1 plus, right, bx plus c x plus 1. So just expand it and be very careful. ax squared plus a plus bx squared plus bx plus cx plus c. Okay, over x plus 1, x squared plus 1. Okay, so again, what's the coefficient for x squared? It's a plus b, right? And here we don't have any x squared, so a plus b must be 0. And what's the coefficient for x? It is 4. So here it's bx plus cx, it's 4x. So b plus c is 4. And then here the constant, there's no constant. So a plus c, it must be the constant, 0. Again, you solve it. It's just a is -2, b is 2, c is 0, c is 2. Okay. So that's why you can write down this integration as a over x plus 1, right, plus bx plus c over x squared plus 1, okay, dx. So here, this first part is very easy to integrate. It's -2 ln x plus 1, right? And then for the first part, it's just x over x squared plus 1. And then for the second part, it's 1 over x squared plus 1. Okay. Then for this part, again, we use the integration, right? We just use the substitution method. I think you can get the answer here, right? So this part we copy, and this part is just ln x squared plus 1, right? Half. And then this part, the integration of this part, because we know tangent inverse, the derivative is just 1 over 1 plus x squared. So if you integrate it, it's just 2 tangent inverse x. Okay, and don't forget about plus c. So here, plus 2 times half, it just becomes 1. Okay, so that would be the partial fraction.